Section 8.3 StatCrunch will work two problems from the ebook. Problem 20, Insomnia Treatment. A clinical trial was conducted to test the effectiveness of the drug zopiclone for treating insomnia in older subjects. Before the treatment with the drug, 16 subjects had a mean wake time of 102.8 minutes. After treatment with the drug, the 16 subjects had a mean wake time of 98.9 minutes and a standard deviation of 42.3 minutes. Assume that 16 sample values appear to be from a normally distributed population and test the claim that after treatment with the drug, subjects have a mean wake time of less than 102.8 minutes. Does the drug appear to be effective? First, we will check the requirements. Requirement 1, the sample is a simple random sample that was stated in the problem. Normality or sample size greater than 30. The sample size is 16, which does not exceed 630, so we will need to check whether the sample data appear to be from a normally distributed population. We only have summary statistics, so we cannot create a histogram or normal quantile plot. However, the problem states, quote, appear to be from a normally distributed population, so the requirement is met. Steps for the hypothesis test. Test the claim that after treatment, quote, mean wake time of less than 102.8 minutes is written as mu less than 102.8 minutes. Step 2, the alternative to the original claim is mu greater than or equal to 102.8 minutes. Since the claim mu less than 102.8 does not contain a statement of equality, it becomes the alternative hypothesis H1. Our hypotheses are the null hypothesis, mu equal to 102.8, alternative hypothesis, mu less than 102.8. The significance level is not stated. We will use alpha equal 0.05. Because the claim is made about the population mean mu, the sample statistic most relevant to this test is the sample mean x bar, and we will use the t-distribution. Use StatCrunch to find the test statistic and p-value. So I've got StatCrunch open, and I'm going to go ahead and go to stat, t-stats, one sample, and this time with summary. I have summary data, and my sample mean, if I scroll back up here from my sample, was 98.9, sample standard deviation 42.3, and the sample size was 16, and my null hypothesis is that the mean equals 102.8, and the alternative is going to be less than, and compute. So my t-statistic is negative 0.3688 with a p-value of 0.35. So what do I conclude here? I fail to reject because my p-value is not less than alpha, and my interpretation leads me to interpret this as the drug does not appear to be effective. The mean wake time based on this data set, we have insufficient evidence to state that the mean wake time is less than 102.8. We can also calculate the confidence interval by editing the options on the hypothesis test window. And let's go ahead and do a 0.9. So we're 95% confident that the true mean wake time is between 80.4 minutes and 117.4 minutes. And notice this interval includes the hypothesized mean of 102.8. The second problem that we're going to do is problem number 22, and I chose this one because this one we have to put the data into StatCrunch. Students of the author estimated the length of 1 minute without reference to a watch or clock, and the times in seconds are listed below. Use an alpha 0.05 significance level to test the claim that these times are from a population with a mean equal to 60 seconds. Does it appear that the students are reasonably good at estimating 1 minute? I entered the data into a StatCrunch worksheet. If you look here, here's the times over here. Although it's not stated, we will assume this is a random sample. Normality or n greater than 30. The sample size is 15, which does not exceed 30, so we must determine whether the sample data appear to be from a normally distributed population. We will use StatCrunch to create a histogram and a normal quantile plot. So graph, histogram, Select my time estimate. And it doesn't look too bad. It's a small sample size. I'm going to go ahead and also do a QQ, normal quantile plot, because we usually get a better estimate with this when we have a small sample. And if I look here, I don't see any pattern other than following a straight line. So I'm going to go ahead and say it's reasonable to assume that the data come from a normally distributed population. Okay, steps for the hypothesis test. Step 1, the claim that these times are from a population with a mean equal to 60 is written as mu equal to 60. The alternative to the original claim is not equal to. Because the not equal to 60 seconds does not include a statement of equality, it's going to become the alternative, and the claim is actually going to become the null in this problem. So our null will be mu equal to 60, our alternative will be mu not equal to 60. Significance level alpha 0.05. Because the claim is made about a population mean mu, the sample statistic most relevant to the test is the sample mean x bar, and we will use the t-distribution. And we're going to go to StatCrunch. Stat, t-stats, one sample. This time I've got the data. So I'm going to select the variable, and I'm going to do a hypothesis test. And remember, we were testing whether the mean was equal to 60 versus not equal to 60. And I get a t-statistic here of 0.53 with a p-value of 0.6043. The alpha level we were using is 0.05. Since the p-value is not less than 0.05, we fail to reject. We have insufficient evidence to say that the students are estimating the time different from 60 seconds. I can also go ahead and calculate my confidence interval. And I'm just going to go ahead and click here, compute. So I'm 95% confident that the true mean time estimate is between 51.9 seconds and 73.5 seconds. The interval includes 60 seconds, which confirms my conclusion to fail to reject the null.